Okay, so this is in response to homework 5.2-3 and it's 15. So they want us to use symbolic integration. So all that means is we're trying to do u substitution. So we want to figure out what to make u equal to, and you usually want to pick the thing that's most complicated. So right here is the most complicated part of this integration. So we're going to make u equal to 1 over 25x to the fifth. And then we want to figure out what is du. So what's the what's the derivative of u? So we want to figure out the derivative. In order to do that, I usually find it easiest if you move the x up to the numerator. So the way we do that is you just make this exponent negative. So this is the same thing as that, and we're still trying to find the derivative. So we haven't yet taken the derivative. We don't yet know what du is. So now I'm going to go ahead and take the derivative of this. So we move the negative 5 out in front, right, to take the derivative. And we decrease our denominator by 1. We decrease our exponent by 1. And it's still going to be over 25. And then we can just go ahead and simplify. So these are going to cancel, and we're going to get still negative a 5 in the denominator. And that 5 went away, and we have to the negative 6. And you always want to try and write it with positive exponents. So we're going to go ahead and move this x to the negative 6 down to the denominator. So we have 5x to the 6th is equal to du. Whoops, and we don't want to forget our dx either, right? So dx and dx. So from here, what I like to do is to now solve for dx. So we have what du is equal to, and I'm going to just rearrange this and get it into dx equals. So I'm just going to do that over here. So right now we have du equals negative 1 over 5x to the 6th dx, and I'm going to solve for dx. So I want to get it by itself, so I'm going to multiply by the reciprocal of this fraction here. So that's going to be negative 5x to the 6th, and what you do to one side in math, you have to do to the other, so I'm going to multiply this side by negative 5x to the 6th, and so these are going to cancel, and we're just left with dx on the right, and on the left side we have negative 5x to the 6th du. So now I can go ahead and substitute this in for here, for my dx, because it's equal to dx, right? And we can put our u in for up here. So now we have the integral of 1 over x to the 6th. So we put in what we found for u and what we found for dx, and everything else in the integration problem is going to stay the same. So it's going to be e to the u, and instead of writing dx, we're going to now write what we solved for dx. So we have a negative 5x to the 6th, and we have a du. This is really important. When you do use substitution, you should always have a du going with it. You don't want to have a u up here and then this be a dx. You always want to make sure that's matching. And then we can go ahead and see that this x to the 6th in the denominator and this x to the 6th in the numerator are going to cancel out. And this negative 5 is just a constant, and we know constants can be brought out to the front of our integral, right? So now we have negative 5, sorry that got messed up, negative 5 out in front, and then the integral of e to the u du, right? So now we can go ahead and take the integral of that. The negative 5 is going to stay. Once we take the integral sign goes away. So we have negative 5, the integral of e to the u is just going to be e to the u still, and plus c, and your final step should always be your final answer should always be in terms of whatever you were given in the original problem. So see how in the original problem we were given x, but now in our answer we have u. So you want to go back and substitute this back in for u here in your answer, which I'm kind of running out of room. But it's going to be negative 5 e to the 1 over 25x to the 5th, and then always plus c, right? So this is your final answer. And you always want to make sure, yep, it's in terms of x, and x is what we were given. So that's it. And you don't want to forget this plus c. The reason why we have this is because there's no bounds. So it's an indefinite integral. And that's all you do. That's it.